In this tutorial, we will implement the view models. So the first view model that we will create is called the upcoming view model. And the purpose of that view model is to show the tasks that are upcoming. So we create a new Swift file. Name the file upcoming view model. And then I'll just paste what's on the clipboard. So what's happening here? The first thing we do is to include the main actor. The main actor, which is on lines 10, prevents an entire class of bugs. Every state mutation in the view model happens on the main thread by design. Most SwiftUI bugs I see in production are threading bugs, pretending to be UI bugs. As you can see, the view model doesn't know about SwiftData. It just knows about the contract, and the contract is within the task repository. So that's the difference between an app that evolves and one that gets rewritten. Also, within the initializer, the view model owns its data lifecycle. The view doesn't trigger loading, and that's deliberate. The view comes and goes. State shouldn't. And also, for the load method, notice there is no partial state here. Either we have the task or we have an empty consistent state. And the function filtered for selected date. It filters the tasks to only those matching the selected date. The logic does not belong in a view. If you filter in SwiftUI View, you will duplicate the logic. Duplicated logic is how behavior drifts happen. And on line 47 for the task function, this is where the view model lives. This can be tested without SwiftUI. View should be questioned and not answered. Now that was an error. View should ask questions but not answer them. So that's for line 47 for the task function. The next view model we need to create is project task view. So I'll just create that view model now. So the purpose of the project task view model is to load the tasks from core data and also delete the tasks in memory, and also to enable the user to reorder the tasks. So let's create the view model now. Project task view model. I'll just paste what's on the clipboard. So we first create the main actor here, which is needed to enable all UI state updates to happen on the main thread, like in the previous view model. And within our initializer, this is where the first code smell happens within production. SwiftUI does not guarantee the view model is created once. Every time it is recreated, load runs again and again, as you can see here. And this is how you get duplicate fetches, flickering UI, and wasted work. Although the load method is a simple method, but at the same time, that's the problem. There is no loading state. There's no retry logic within the load method, as you can see. And also, errors are just strings. In production, this gives you UI states you can't reason about. Also, within the load function on line 31, this works perfectly until the app restarts, because this order is never persisted. As you can see, there's no repository.save or any persistence going on. And also, persistence ordering would require an order index property. And this is also one of the common SwiftUI performance bugs, since every small change triggers a full reload for the toggle and for the delete. With 10 tasks, you won't notice anything, but with 1,000 tasks, the app will feel broken. So delete reloads everything. As you can see, it's a simple function, but it's also wasteful. In production, you either update local state optimistically or pay for it. So what we will try to do now is to do some refactoring to get this view model how it should be. So the first thing we need to do is to update our publish variables so that they're right properties using set. So I'll just type that manually. Private set var task. So we create a new task item array, and we do the same thing for the error messages. For the error message, make it set. And also we need to create another variable called didLoad. Private var didLoad equals false. And then we can update the load function because it needs to be, the load function on line 21, it needs to be load if needed. That function doesn't exist at the moment, so we need to create that function. I'll just create that now. Function load if needed. Also need a guard statement. Guard not did load, so if it didn't load, then we just exit the function. If it did load, then did load is assigned to true, and then we just call the load method. Within the load method, we also need to do a little update as well. We need to display the error, assign the error message to nil. And also we need to clear our array, empty our array. And for the toggle completed method, we need to do the following. So just type in guard let index equals task dot first index. So we're attempting to locate the record using the ID to ensure that it's equal to the ID of the task. And if it's not found, then we just exit the function. Oh, that should be task there. Next thing we need to do is an optimistic update. So we need to assign the task index is completed to toggle. So update it so it's either true, false, as in the task has been completed. And we need to do the same thing for the delete function. So I just copy what we've done for the guard functionality and then paste it in the delete function, and then type the following: let removed equals task dot remove at index. So it removes the task using a given index. And then if an error happens, we need to do the following: task dot insert removed at index to remove the record that was inserted. So that should be loaded if needed with a capital I. I'll just compile it. It's compiled. The next view model we need to create is the edit task view. And the purpose of this view model is to enable the application to perform updates and deletes so that we can insert a new task or delete a new task. Edit task view. Edit task view model. And I just paste what's on the keyboard. That's on the clipboard. So, as the view stands at the moment, the view model is clean, it works, and it is exactly how most task apps end up, shipping subtle bugs. So let's go down to the save function. As you can see, the save function returns a boolean. Using a boolean is not really friendly error handling because the UI cannot tell if this action failed due to validation, persistence, or something recoverable because it only returns a boolean. Also, on line 54, validation is only performed on the title before saving. In production, users will absolutely end up with end dates before start dates, invalid colors, empty projects, and you probably store a lot of garbage that way in the application. So let's improve this view model. I'll just paste the code from the clipboard. As you can see, we've made a few improvements. Now the save function returns a result with an error and not a boolean. So because it's wrapped within a save result, it enables us to have access to other type of information, not just boolean data. And that's something what the UI can work with as well, so the users understand the application. This is what a real task app looks like. Fewer branches, fewer places to forget logic and state. and it makes it easier to trust the application and to work within the code base. In next week's tutorial, we'll be implementing the reusable UI components. That includes like daychip, app themes, colors, and everything else.